Hello everyone, my name is Russ G, and today I'm going to be telling you about a new motor generator design that's unlike anything that you normally see. This design uses Lenz's law to actually help it function properly. It does not drag, and it creates energy much more efficiently. It is called the infinity motor. The person who originally thought it up was Mark Wessling. And I'm going to show you this PDF document that is in the description of this video, and basically it shows you what the design looks like, and you can envision it this way. This document will be in the description. Please read it. It explains to you how this functions better than I can. So let's get started. Basically, there is a main rotor right here, and it has little rotors on it that have motors on them that spin them, and there are magnets placed within these rotors. On the other side of that, there's pickup coils, and what this does is these little motors spin and create a Lenz's law effect against these coils when they are shorted out or have a load. Now what happens is that this little rotor is being forced one direction, which makes this big rotor spin the other direction. Now you're using Lenz's force efficiently and actually rotating another object while making electricity. And the Lenz's law effect makes this main rotor rotate, and on the other side of that shaft you can put another generator. Here is what it looks like. The main rotor turns one direction as the little rotors turn the other direction. Once you get the device built, you can also put a pickup coil on the other side of this main shaft. So if the other coils are in this area, right here, down the end of the shaft you can put other pickup coils. So you're using Lenz's law to rotate a main rotor shaft. Again, this document will be in the description. Here is the device. This is called the infinity motor / generator. What I have here is a main rotor here with little rotors on motors that have magnets placed in them. This main rotor rotates, and it has a commutator to make the little rotors spin to give them power, as you can see right there. There are coils placed around here so that these magnets line up even when they spin. On the other side of this, which in this model does not have the other rotor or coils, this is where your generator would be placed. Now I have each one of these coils has around 75 to 80 foot of wire. There are 16 coils on this model, and that is around 1,200 feet of wire. There's over 1,200 foot of wire on this model. I have each one of these coils hooked up to its own bridge rectifier into a bank, a cap. Each one of these terminals is one coil. This is DC output. As you can see, I have all 16 coils hooked up here. Now this is just an open source project, so this is the initial first build. As far as me and Mark are concerned, nobody has built this particular device before that I know of. Again, this is an open source project. Feel free to do whatever you wish. If you do something and you find something out, please, you can get back with me or Mark via my YouTube channel, which is RWG42985. Now right now this is still in testing phases, but I wanted to get it out there since it's an open source project and show you that this has been built and it does function. It still has its own issues that we are working out. Nonetheless, everything's going to have problems when you build it. So I'm going to go ahead and prove to you that Lenz's law effect will rotate this main rotor when you short these coils out. I'm running on a 5-volt power supply right here, and I will just be running those little motors and short these coils out. Okay, now what I have is this 5-volt power supply hooked up to this commutator, which is hooked up to these little motors that have the little rotors. Now when I turn this switch on, what's going to happen is the rotation of this little motors are going to push the big rotor until they get up to speed. Once they get to speed, this big rotor will stop spinning because all of the coils are open. Now that the little rotors are up to speed, what I can do is short out these coils, and that main rotor will start to rotate. I just have a bar, and I'm going to short it out against these pin terminals, which are connected to the coils. So you can see that Lenz's law is rotating that main rotor because there is now a drag on the magnets on the little rotors. This is the principle behind this design. This design right now is not an over-unity device. This is just proving the fact that you can use Lenz's effect to your advantage. Now, if I take this bar off, you can see that the main rotor slows down. These motors are running at 5 volt. It's approximately 200 milliamp to run these motors. I can get approximately 4.5 volts out of each one of these coils when the rotor is spinning at full speed, when the little rotor is spinning at full speed and the coil is directly under it. When you rotate this and it starts to drag from Lenz's force because you're drawing a load from this coil, the output drops because you're no longer hitting that coil at maximum speed all the time. I'm going to turn this off now. You can hear the rotor spinning down. Right now, I have 4 neodymium 12mm by, I believe, 3mm magnets on the end of these rotors, as you can see there. This whole rotor is north facing the coils, and this whole rotor is south facing the coils. After building this model, I found out other things that can be improved to make this run much more efficiently. Again, this is an open source project. It is not an over-unity device right now. This is just proving the concept of using Lenz's force to rotate a main motor shaft while still creating electricity. And basically there's no drag in the system. You're using Lenz's force to your advantage. Alright, everybody is welcome to upload this video wherever they would like. Please post this video anywhere you'd like. Again, this is open source, and refer back to this first model and this PDF, which will be in the description. If you re-upload this, please attach the PDF. Sayonara.